Hello, everyone. We're Team 19 for the IBN. Our application name is Demeter. Our team members are Ghislaine Bugingo, front-end developer, Johan Costa, cloud architect, Jacqueline Lamb, UI UX designer, Jackson Yuan, IoT developer, Michael Pizzeno, product lead, Timmy Wag, backend developer. And our current problem is, after reviewing some research by the Food and Agricultural Organization of the United Nations, there's an indication that the worldwide food production will need to increase by 70% by 2050 to meet growing demand for food. Farmers who have been growing regional crops for decades, utilizing the same practices, are now finding they need to adapt quickly due to climate change, water scarcity, and infertility of the land. Now, farmers are required new and differentiating practices for regions affected by climate change.
Our solution offers cutting-edge technology that determines the best utilization of resources to maximize crop yields while minimizing costs through data analysis at the regional level. Using machine learning, IoT, and computer vision technologies, our application can make insightful recommendations for farmers on how to best employ their resources. For example, through our recommendation engine, intelligent insights can be determined for optimal soil nutrient levels and irrigation and fertilization usage. Our app also leverages all the inputs to form an easy-to-use dashboard that makes a large farm feel like a backyard garden.
Okay. So after the user logs in, they can click on the dashboard, and then they can simply click on anyone on the dashboard screen to make the sidebar go away. And from there on, yes, and from there they have the entire view of the dashboard. So the dashboard provides you with information of, for example, like the weather information, and then the total amount of resources used so far, such as water, fertilizer, pesticide, and it also gives you a recommended system that uses the model. The model pulls live information on real-time information from the API, from the sensor, and then it runs the model and gives the results, which gives the recommendation of how much water you need to use in fertilizer as well as pesticide. And there's also a line plot that tracks the progress of the growth of the plant, of each crop. And then there's also an alert system which provides you information about how to maximize your growth or your resource usage. And there's also IoT sensor data, which collects low-level information data, such as the current soil metrics, and as well as the current soil micronutrients. And there's so it's like this feature is actually really important for farmers that have bigger farmlands. So like with the computer vision, with all the camera put in place, they don't have to physically go inside the field and walk around to check things out. This feature helps them just monitor the crops through the screen. Yes.
And then our next feature is creating a virtual layout of the farmer's plot of land. And so what they would need to do for the first step is input the height and the width, and then select the units. So in this case, let's pick a 3x3 acre farm. So we'll select our width, height, and acres. Then our next step would be to search for the plants that belong on the farm. And as we can see, we have 3 existing plants, but let's try to add a tomato. We'll click on this plus sign to add to our list, and then once we're done with that, we can lay out our plants. So as you can see, here's a little diagram of the width and the height of our farmland. So we'll select a square region first, and then select a plant that goes onto that region. Let's just select the potato for now, and that should appear on our left-hand side of the selected square. And then you would continue doing this for the rest of the plot of land, first how many plants you have, and then you should get something like this in the end. And then once you're finalized laying out the plants, we can then view our farm layout and additional details about each plant. So say we want to know more information about our tomato over here, it will give us a little pop-up of the gallons of water it needs, the soil recommended, and how much pesticide it probably needs for your crop yields. And then finally, once you're done laying everything out and viewing additional details, you can compare or look at the costs of your entire virtual layout. So we see a breakdown by plant of tomato, carrot, corn, and potato. Looking at the total quantity, it might yield the market price per unit, the cost for you per unit, labor, machinery, and resources such as water or pests it might have. Then it'll give you a total farming cost for your virtual layout, and you can download this information clicking on this button as like a CSV or PDF file. And then once you're done creating your layout, you can actually view additional ones. So right now we just have 4 that we've created as a mock-up, and you can compare the prices, resources, and crops for each to maximize your crop yield and minimize your costs with low risk. So that's it for our demo. So we're going to continue to our presentation.
So now in terms of the user flow and architectural map, a user interacts with the dashboard where he'll receive push notifications via Twilio. And an external provider, we have Sensor Swarm and Camera Swarm, which encompass our IoT sensors. These all feed into a server, which is housed in and collects data in IBM Cloud Object Storage. This data then is processed with Maximo Visual Inspection and at on-premise ML processing on the IBM Cloud. All this data is then served into a privatized database, which then interacts with an API that sends all the aggregated and collected data into a dashboard.
So now let's look at how we track the success. We are comparing previous crop yields and resources like water, fertilizer, pesticides that are required to similar metrics after using our application. The aggregate and individual agricultural costs can be measured like each year through the virtual layout tool and dashboard insights, so that the farmer can monitor for a downward trend in cost and an upward trend in the yield. Our future steps are we'll try to deploy IoT sensors and cameras to farm operations around the globe. Then we'll automate the create layout process by taking satellite images and by creating the virtual farm. We'll use robots to automate the data sampling process, like soil, plant samples, or capture images across farmland. And finally, we'll deploy the application on IBM Cloud to increase scalability and robustness.